So, hello everyone, my name is Tanmay. Welcome back to the channel. In today's video, we are learning about one of the most important topics in computer network, the link layer, also called as data link layer. And it has two types, data link and physical link layer. So, by the end of this video, you will have clear understanding of how data actually moves from one device to another safely and reliably. So, let's get started. Ah, so this is the basically typical OSI model image. It has layers. We have studied application layer, transport layer. So now it's time for link layer. It's go to another slide. So introduction. Yeah. So the link layer sits between the physical layer and the network layer in the OSI model. Think of it like as a traffic controller of the network. It ensures that the data travels smoothly between directly connected devices. It handles things like framing, breaking data into the chunks, error detection, and deciding who gets to use the medium next. Without the link layer, our data would just be a random electrical signals with no structure or reliability. So these are the topics we are going to cover in this video. Uh, so yeah. So first of all, basics. So, link layer is responsible for node-to-node delivery, meaning it ensures data travel correctly between two devices connected on the same network. It also deals with MAC addresses, which are the like physical IDs of network devices. It converts the bits received from the physical layer into frames, which are structured data units. So basically, for example, if you send a message on WhatsApp, it's the link layer that ensures that your data reaches your router correctly before it sends to the internet. So error detection and correction, it's a very important part. So basically during data transmission, errors can occur, we all know. So there are two types of error, single bit error where one bit gets flipped, burst error where group of bits are corrupted. So yeah, so a simple example you can take, imagine you are sending a message that say hello, but noise changes it to hexo. That's receiver checked using these methods, detects the error and either corrects it or asks to reset. That's how to we maintain the reliable communication. So these are the three techniques, detection technique. We will see with the example of a diagram to so that you can get a clear understanding. So let's start with a simple parity check. So in this image, you can see on the left, you can see the sender has a binary data sequence like 1000011. Now the sender computes a parity bit. Let's assume we are using an even parity. That means the total number of ones in the message, including the parity bit should be even. Here the number of ones are 3, which is odd. So the sender adds a parity bit of 1 to make it even, which will be 4. So the transmitted data becomes 1000011. So now on the receiver side, the receiver again computes the parity of the received bits. If the number of ones is even, it means no error occurred, data is accepted. If it's not even, it means error happened, data is rejected. Okay, so yeah, this is called single bit error detection. Now let's come to the next part, checksum. So what is checksum? It is slightly smarter approach. So for example, on the left you can see sender has a set of data segments. So this binary blocks together kind of sender adds this like kind of like adding numbers in the normal math, but with binary addition. If there's a carry, it is wrapped around and added again. After summing up all the blocks, the sender takes the ones complement of the sum. That's become this checksum. Here's the checksum is, you can see that 110 110 10. So the receiver performs the same addition. Receiver also performs the addition. It adds all the received data blocks along with the checksum. If the result is all ones, you can see here ones. So that means that data is correct and accepted. If it not, some error has occurred. So basically, these are used for large block of data, and in real, you can see in it TCP and IP checksums are used. Now coming on to CRC. So what is CRC? It's basically cyclic redundancy check, the most powerful of the three. So here the sender takes data in bits, say m bits long, and appends n zeros to it. Then it divides this long bit string by a fixed divisor using binary division. Okay. So the remainder from this division is the CRC value. This remainder is added to the original data and complete frame is sent over the network at the receiver side. At the receiver side, the same division is performed on the received data. Okay. So if the remainder is 0, you can see it means no error, it is accepted. If the remainder is not 0, it is rejected. It is also it is used in Ethernet frames, USB, and many data transmission. As you can see, it is most powerful among three, and it's very reliable and can detect burst errors. Okay, so these are basically the error correction techniques: forward error correction, automatic repeat request. Basically, it receive detects error and request retransmission, like we have studied go back in our previous units. So that's so random access control protocols. So now what happens when multiple devices try to send data on the same medium? Now collisions can occur. Just like when two people talk over phone and at the same time, you can see the overlapping of word miscommunication takes place. So to manage this, we use random access protocols. For example, Aloha, 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 the simplest one, in which devices send whenever they want. If there's a collision, there's a random time and resend. Slotted Aloha add time slot. It basically add time slots to reduce collisions. Okay. So now coming over to DOCSIS. DOCSIS is data over cable service interface specification. So now you might be wondering what exactly is DOCSIS. So it's the technology that allows internet data to be transmitted over the same coaxial cables that deliver your cable TV. So basically the same wire that brings your TV channels at your home can also bring your high-speed internet. That's the magic of DOCSIS. Let's understand how it works. Okay. At your home, you have cable modem, right? That's a device which connects to the cable line and gives you internet. So at the internet service provider, your ISP provider side, there is something called CMTS, which stands for Cable Modem Termination System. This CMTS manage all the connections from different user in an area and ensures smooth data transmission. Okay. Yeah. So basically, the communication between the cable modem and CMTS happens over two channels. One is downstream channel for data going from the internet to you, and upstream channel from you to the internet. So DOCSIS divides the bandwidth smartly between these two directions. So briefly, I'll talk about the components of DOCSIS architecture. It's the cable modem, which is at the customer premise. CMTS, as I said, it is the ISP side, Internet Service Provider. Hybrid fiber HFC coaxial network. Basically, it combines the fiber and coaxial cables to cover long distance effectively. And you may be thinking why DOCSIS is so popular. As you know, here's the advantage. So it offers high-speed internet, supporting gigabit level speeds, simultaneous use of TV and internet services on the same cable. It is cost-effective and all. Better quality of it provides better quality of service. Yeah. So basically, this is the DOCSIS 3.1 cable plant. It is as same as we have discussed in our previous slides. It's like internet service provider, subscribers. You can see downstream speed is in gigabytes. So that's so now coming on to link virtualization. Basically, it's the idea of splitting one physical network link into multiple virtual links, kind of like having multiple Wi-Fi networks on the same router. This allows flexibility, better resource use, and supports technology like software-defined networking (SDN) and cloud computing. So basically, why are we learning this? It's all about making networks more scalable and efficient. Okay. Yeah. So now coming on to multi-protocol label switching, it is also important. Basically, it is an advanced technology. It speeds up data forwarding by using labels instead of full IP address. So basically, it doesn't take the full IP address checking at the destination. It doesn't check the full IP address. It just read the label and forward the packet quickly. So that's why it supports traffic engineering and quality of service. Basically, it means it can prioritize important traffic like video calls over less urgent data. It is widely used by internet service provider and large enterprises to build fast and efficient networks. Okay. So now coming on to the summary part. So in this video, we have discussed link layer role and functions, error detection and correction, very important like the parity, single parity, checksum, CRCs, DOCSIS for cable internet, how cable TV internet are, how we internet is reached in our homes. MPLS, link virtualization, channel access protocols. Okay, so let's discuss few the key takeaways. So basically, the link layer handles data transfer between devices on the same network. It ensures reliable, error-free communication using detection and correction techniques. Okay. It controls how multiple devices share the medium using random access protocols, and DOCSIS, MPLS are real world application of these principles that makes modern internet communication fast and reliable. So basically, in short, we can say that the link layer is the unsung hero of networking that keeps our digital world connected. Okay, fine. Yeah. So thank you so much for watching. If this video helped you understand the link layer better, don't forget to like and subscribe for more networking lessons. Drop your questions in the comments. I'll be happy to explain any concept in detail. So until next time, keep learning and keep exploring the world of computer networks. Thank you so much.